Welcome. In this video series, we're going to look at properties of logarithms. And so really we just want to be able to use these properties correctly. And we're going to use these properties to expand and condense logarithmic expressions and then also evaluate using the change of base property. Now, in previous videos, we mentioned that logarithms are a lot like exponents. So the properties that we know and love from exponents transfer to some extent into logarithms. We just need to be careful on how we use them. So we're just going to dive in and talk about the log laws. I call them log laws instead of log properties. I just like the alliteration. But the first rule is product to sum. So we have to be careful in how we apply these. So notice that this says the logarithm, and then inside of the logarithm is the product, and that becomes an addition between two same base logarithms. So we have to keep the base, but we just split the product inside into two logarithms. Note it's not the other way around. So it is not log of x plus y, okay, log base b, is equal to log b of x times log b of y. That is not a thing. Okay, so don't do that. Just as we have product to sum, there is quotient to difference. Okay, so it says that the log of a quotient, so the quotient is inside the logarithm, right? Quotient division. And then we have that becomes the difference of logarithms. So again, keep the base A throughout, or B, whatever you want to use. And then just make sure to have a difference or a subtraction between the two. Okay, so product to sum, quotient to difference, and then the last one that we're going to have is that the power rule. So this just says if we have an exponent inside the logarithm, so x to the r, that exponent has to come out in front. Now, just a word of caution: r is on all of the stuff inside. So for example, something like log base, I don't know, 4 of 3x squared, this is not equal to 2 log base 4 of 3x, because the 2 is only on the x, it's not on the 3 and the x. If you wanted to say this was true, what we would need to see inside is that we'd have the 3x, all of it would have the exponent of 2. Okay, then this statement is true. Okay, so just be careful with these. There's a lot of little nuances. Don't get tripped up. Okay, so before I go through these, I want you to pause the video and try using each one of these. Each one of these uses a different rule. I want you to write an equivalent expression for each of these. Okay, so for the first one, we notice that inside the logarithm there is 2 to the x. Oh, there's an exponent on the 2, right? So that means I can use the power rule. Okay, so the x can come out in front as a coefficient, x times log of 2, and I'm done. There's no, we can't apply the product rule. There's no product inside. There's no quotient inside, and we've done the power rule, so we're good. For the next one, we do have a product inside. In fact, we have 2 of them. So you could, if you want to think of it as 2x times y, you can. You can write it as ln of 2x plus ln of y. Okay, writing that last product as a sum of 2 logs. And this is good. I didn't say in simplest terms, or is using as many logarithms as possible, so this meets the criteria for the problem. But if you wanted to go further, which I challenge you to do, you would recognize that 2x is another product, so you would write this as ln of 2 plus ln of x plus ln of y. Okay, and now for some people, when you get to expert level, I, for example, can go right to this last statement. I can skip that intermediate step. So as you get practice, you'll be able to do this more easily. Okay, and for this last one, you could do log base 3. Log base 3 of 12 minus log base 3 of x, and this again meets the criteria, but you could also say that log of 12 is 3 times 4 or 6 times 2, but 3 times 4 happens to work out pretty nicely, because you would get log base 3 of 3 plus log base 3 of 4, minus log base 3 of x, and then this first one is 1. 4 you can write as 2 squared, and that would become, so if it's 2 squared inside, right, the 2 would come out in front, and so you'd have 2 log base 3 of 2, and then minus log base 3 of x. Now this last one is a bit of a stretch. Really, if you get to this step, and it just says write an equivalent expression, that's good enough. Okay, so we have the log properties, and now this next screen, I find students really like this screen, so you might want to pause the video, write all these down so that you have the exponent laws and log laws all together. So this first one is kind of the zero exponent property, and its equivalent in logarithmic form. Exponent of 1, and that base b of b, property with logs. The next one is the product to sum law for both exponents and logs, and then quotient to difference for exponents and logs. Okay, it's kind of interesting that you notice that the inputs and outputs switch. That's because we have logs are inverses of exponents. So so notice we put in a subtraction in exponents. For logs, we get out a subtraction. Kind of interesting. Okay, and then this next one is this next one here is supposed to illustrate the practice or the power rule, and then this last one is kind of the inverse property, if you want to think about it like that. Okay, so this is just a short little video on exponent properties and more so log properties, and now we're going to put these into action and really have some fun with expanding and condensing expressions.